Accidentally, that's it. He decided not to add where Tyler stole. You think I haven't seen this kind of thing happen before? Well, Jason, I'm an excellent judge of people. Would you took the wrong message from that experience?
Hello, everyone. How are we doing today? No one's going to say hello? What's up? And then give me a high five. Oh, I got a thumbs up. I'll take that. Everyone doing okay today? You can say hello or put a uh, message in the chat. Um, where are we? Where are we? All right. All right. I got one message. Oh, I'm doing great. I'm doing great. Just a little bit nervous as usual because we have so much to cover. You guys gotta let me know if you guys have questions or if you have concerns, so I can make sure we're all on the same page. Okay, it is recording. It is 5:31. I have more people coming in. Okay, Mason. All right. Don't forget to turn your cameras on. Welcome, everyone. I am going to looking for my spot. Let me share my screen right quick now. All right, so we start with no announcements. I don't think I have any announcements. Maybe I do. When I remember, I'll let you know. All right, so first things first, let's go ahead and align ourselves and our minds. We are finishing up module 2. I go through most of the content circles, but we have one last issue that I need to take care of, circles. And after that right here, we'll be moving into module 3, and we're doing mainly functions. We'll learn what is a function, how you find the domain and the range of a function, and then hopefully we can get to our library of functions. All right. So that's kind of where we are at. And so brain is thinking. Oh, brain is saying it's ready to go. So let me switch us over to my iPad. Let's get started. I forgot to turn the thing on. I'm looking for, oh, there it is. Right. I have solved the problem. All right, you guys can see my screen. Right, so a quick recap. We were looking at circles, or rather the equation of a circle. And if I have x minus 2 squared plus y plus 5 squared equals 36, the key thing here was us looking at this equation right here, we should have been able to determine, based upon the elements of the equation, that this is a circle. First things first is we have a plus sign in the middle. You have two things being added together, and each of those are being raised to the second power. Once you have those basic elements right here, we have a circle. Now that we have recognized we have a circle, we have to identify two features of the circle. One, the center, which we call h, k, and the radius. which we just called R. The center came from the two numbers, in this case right here, -2 and 5. Your center is going to be the opposite of those values, and so that's going to be 2, -5. And your radius came from the value on the other side. The radius is the square root of that value. I chose 36 because 36 is a nice round number. I can take the square root of that, but it didn't matter. If the number right here was 10, then the radius would be the square root of 10. All right. Questions there on our little primer, our little bit of a reminder. Okay, so the last thing that we had to cover today was that sometimes, unfortunately, the equation of a circle is given in the general form, not the standard form. Remember, this right here is called the standard form of an equation, circle equation. And if your circle is given in general form, circle equations in general form. The thing is that if your equation is given in general form, you first have to take it from general form and convert it into standard form. And you have to do this through a process called completing the square. So to go from this piece right here over to the other side, you have to complete the square. Now, the nice thing right here is that completing the square is a fun process because you get to have fun when you're completing the square, right? But the thing is, though, it has a few steps to it. And because of that, sometimes it can be difficult to follow. And so because of that, we're going to need for us to just focus for a second. So completing the square is what we are covering now. And I have to give us a little bit of background before I go into this whole process of completing the square. A binomial is simply a term with two pieces in there. Say, for instance, x plus 3 is a binomial. A squared binomial is simply a binomial that's been raised to the second power. Not too bad, not too bad. It turns out that a squared binomial can be expanded by following this basic rule. X plus 3 multiplied by x plus 3. So if I have x plus 5 squared, that's x plus 5 multiplied by itself, multiplied by x plus 5. Whenever you're looking at a binomial, what you're simply doing is you're just putting it next to each other. And then you're following the FOIL technique of FOIL first. So this times this, that gives us x squared. Outer, x times 3, that gives us 3x. Inner, 3 times x gives us 3x. And then last, 3 times 3 gives us 9. And the middle terms will combine because they have the same power. And so then this is going to be x squared plus 6x plus 9. This binomial x plus 3 squared is equals to this thing right here, x squared plus 6x plus 9. And this right here is called a perfect square trinomial. Perfect square trinomials come from binomials that were raised to the second power. Let me pause right there. Question. Let's do one more. Let's say I have x minus 5 squared, and I want to work this out. This is simply going to be x minus 5 multiplied by x minus 5, and I am working this out. X times x is x squared. X times 5 is negative 5x. Negative 5 times x is negative 5x. And then negative 5 times negative 5 is plus 25. And then this result will be x squared. These two will combine, giving us negative 10x plus 25. And again, this is a perfect square trinomial. Questions there? Well, it turned out that mathematicians got tired of doing this process. If you really look at this process very carefully, you'll notice that there is a pattern. I do not have to go through all of these steps to get to this step right here. I can kind of skip. If I simply recognize what's going on, I can kind of skip to the answer down here. Take, for instance, x plus 10 squared. I tell you that this is going to be x squared plus 20x plus 100. Can anybody tell me how I got this trinomial right here? I'm looking at the previous two examples. Anybody? I'm waiting.
For the second one, you added 10 plus 10, and then you multiplied 10 by 10 times 10 for the third.
Exactly. If you look very carefully, when you're foiling this out, the middle term always comes twice. If you look very carefully, the term right here always comes twice. So basically, I'm just multiplying this by 2. Negative 5 multiplied by 2 gives me the negative 10. And then negative 5 squared gives me the 25. And of course, the first term is just x squared, right? And so knowing this pattern, I can take any x minus 11 squared and immediately write out the answer. X squared minus 22x plus 121. Questions there? Now, it turns out that after mathematicians did this for a while, they kind of get bored with themselves and they say, what else can we learn about this process right here? And then they quickly realized is that there is a connection between the last two numbers. Let me highlight this right here. And my highlighter right here. See, this value right here is 6. My highlighter is not happy. All right. See, this value right here is 6. And then this value right here is 9. There is a connection between these two numbers. This value right here is negative 10. And then this value right here is 25. This value right here is 20. This value right here is 100. Does anybody know what that connection is? To go from the middle term to the last term. How? Oh, looks like my iPad is not happy with me. Let me go back. But while I'm waiting, though, anybody? What's the connection between those two values, the middle number and the last number? I stopped on twice. Huh? It's not a good sign. Huh? Nothing. No. Anybody been able to figure out the connection between the two terms? All right, I will tell you. If you take the middle term and then divide it by 2, you take the middle term and then divide it by 2, 6 divided by 2, and then you raise it to the second power, you get the last term. The reason why we're dividing by 2 is because there are two numbers, and the numbers are always the same, and that gives us the value that is squared to give us this number. And so, for example, 20 right here, if I take 20 and I divide it by 2 and I square it, that will give me 10 squared, which is 100. And to go to that last number right here is you simply have to do that. You have to just simply divide by 2 and square it out. Does that make sense? Come on, guys. I need to at least turn your cameras on so I can see if that makes sense or not. Please and thank you.
Yep, that makes sense to me.
All right, good. And so it means that if I was to give you this question right here, say I have this, I have x squared minus 22x plus, and I'm telling you the last number is missing, you can find this number. You can look up here and you can tell what the number is. But if I say this right here is a perfect square trinomial, and I said, please, kind sir, please, kind ma'am, can you find the last number to right here? You can find this number. You simply use this value right here and you use the formula b divided by 2 squared. All right? So I would like you to try that for me, please. All right, so our first discussion for today. Today is September 3rd. I'll show you where it is in a second. I want you to complete the square. I want you to, this is where the name of the whole process comes from. Technically, it should be complete the perfect square trinomial, but we shortened it and we just simply say complete the square. And what we have, I have 3 examples, x squared plus 8x plus, I want you to find the last number. Then I have x squared minus 16x plus the last number. And then the third one, x squared plus 5x plus the last number. I want you for each of these to find the missing value that will complete the square. I'll give you about 2 minutes. Go ahead, once you have the answer, post them to today's discussion.
Your screen went away.
Yes, it just gave me an error. Hold on, let me might have to restart Zoom. Give me 1 second.
Recording in progress.
All right. Hopefully it will not thing anymore. The last one is a little bit tricky, huh? Yeah, I'll give you one more minute. All right. Who wants to help me with the first one? What's my missing number?
16.
16. That is correct. 8 divided by 2 is 4. 8 divided by 2 is 4. And then 4 squared is 16. Any questions there? Now, bonus. Once you have completed the square and you've made a perfect square trinomial, it is a short jump to write the original binomial. X plus 4 squared is what results in the x squared plus 8x plus 16. Okay, and how did I do that? I simply took this middle number right here and I divided it by 2. 8 divided by 2 is 4, and so it has to be x plus 4 squared. If I go back for a quick session, you'll see that's exactly what happens right here. The original value right here is x plus 3 squared. Down here, 6 divided by 2, that gives us the 3. Down here, the original down here is negative 10. Negative 10 divided by 2 is negative 5, x minus 5 squared. And so going in reverse is much, much, much easier because all you're doing is dividing by 2. And of course, writing it in the correct format. So write open parentheses x plus 10 squared. Again, if I gave you this down here, 20 divided by 2 is 10. That's the perfect square. Someone else help me with number 2?
64.
64 is correct. Do you want to take a chance at what the going to be the binomial? Maybe
I got 8 and 8.
it's going to be x. Is it plus 8 or minus 8?
Uh, uh, uh,
That's right. It's going to be minus 8 squared. And the last one, someone help me. The last one, the tricky one.
6.25.
6.25 is correct. How do you get that?
You divide 5 by 2, and then you
5 divided,
multiply
that's
2.5 by
2.5.
2.5.
And 2.5 squared is 6.25. Now, if you decided to go the fraction route, you simply write it as 5 over 2, because that's the first step, 5 divided by 2. And then when you square that, 5 divided by 2 squared, that gives us 25 over 4. Of course, 25 over 4 is the same thing as 6.25. So you could have either had 25 over 4, or you could have had it as x squared plus 5x plus 6.25. Both of those are correct. And if I want to write it in its factored form, I would simply write, again, this is the piece I need. So I can either write it as x plus 5 over 2 squared, or x plus 2.5 squared. Let me pause right there. Any questions?
No.
So then how does this help us with circles? Now that we have this knowledge right here, how does this help us with circles? Let me show you. So we are going to convert from general form to standard form. I guess I should say convert the circle equation. Convert the circle CIRC equation from general form to standard form. Take, for example, I have this right here. I have x minus 2 squared plus y squared minus 4y plus minus is what I'm looking for. Where did my eraser go? There it is. Minus 8 is equals to 0 right here. And I have this equation right here, but it is not in standard form. If you recall, higher up, standard form is in that lovely format, the plus sign in the middle, my 2 parentheses equaling a number. And of course, I have the squares on the outsides. And then I have on the side x minus h and then x minus k, right? That's what my standard form is. So if I'm looking at this equation, the first piece is okay, because this is a binomial squared. Hint, hint. Keep track of that word right here. This is a binomial squared. And so, oh, wow. Part of the equation is at least worked out for us. We got to do the other part. And so these are the steps that we need to do to work this other part out. What I have to do right here is I have to identify the variable that I am completing the square for. In this case right here, let me put my line right here. I am completing the square for the y variable. And so what it means is that the y value, I'm going to have to divide by 2 and square. Now that I know I'm focusing on y values, I can then flow through these sets right here. First things first, you want to move the constant. In this case right here, the constant is the number 8. And so I need space. So let me start over here. X squared plus y squared minus 4y minus 8 equals 0. And so my second step right here is I have to move the constant. So I'm adding 8 over here to both sides. So my new equation is x squared plus y squared minus 4y equals 8. Let me wait for you guys to catch up. You know the red thing in the bottle? Catch up? No? Maybe? A little bit? And now is the importance of what we have learned up until this point right here. If I look at this right here, this slide right here, what happens is this can become a perfect square trinomial if I can find the number that is missing. Just like in the examples we did a while ago. If I can find that number, I can complete the square. Yes? But the only thing is that this is an equation. So if I'm going to do something to the left side, I must also do it to the right side. If I'm adding 10 on one side, I have to add 10 on the other side. If I am adding 55 million to one side, I have to add 55 million to the other side. And so the next step right here is to complete the square. So find the value that completes the square. And of course, I'm going to write the formula for you. It's going to be b divided by 2 squared, that middle value. So what's my b right here? My b is -4. And so what I have to do is I have to take -4. I have to divide it by 2, and then I have to square it. -4 divided by 2 is -2. -2 squared is 4. And so it means I have to put a +4 on both sides of the equation. Questions there? Now that I have done this, I have to convert the perfect square trinomial into a binomial. And so this becomes x minus 2 squared plus y minus 2 squared equals 12. Is everyone clear on how I got the y minus 2? How I went from the perfect square trinomial to the y minus 2 squared? What I did was I did the bonus. If I have this right here, a perfect square trinomial, I can write it as a binomial raised to the second power. Questions there? Questions there?
So
Correct.
if you basically redid everything. So if you just if you basically foiled that last equation, it would break down into the equation before, like the
Exactly.
x minus 2 squared plus y squared.
Exactly. And you can always do it to double check. Y minus 2 times y minus 2. Y times y is y squared. Y times 2 is negative 2y. Negative 2 times y is negative 2y. Negative 2 times negative 2 is plus 4. That's y squared minus 4y plus 4. So these two things are the same.
And you just leave the x plus 2 squared alone.
It was already how as we needed.
Gotcha. Cool. Thanks.
And so now I can say that the center is going to be 2, 2, and the radius is going to be the square root of 12. Questions there? No problem, Ms. McDonald. Okay. Questions there? All right. There is one caveat to this entire process. There is one caveat to this entire process that can make it a little bit challenging. And so this is something that you have to be aware of. This is our last step. So, example. Let's say I have this right here, 3x squared minus 6x plus 3y squared plus 4y minus 4 is equals to 0. This is an equation in standard form. In fact, everything is just crazy. Everything is just up and in the air. To find the center and to find the radius of this circle, I am going to have to complete the square. Okay? And in fact, in my step 1, right, choosing the variable, I have to complete the square for both x and y. So I have to complete the square for both x and y. Okay? So I have made that decision. My next step, step number 2, is to move the constant over. And so I'm going to add 4 to both sides. Plus 4, plus 4. And so that leaves me with 3x squared minus 6x plus 3y squared plus 4y equals 4. And this is where the caveat comes in. I have not mentioned this up until this point because it has not been necessary. But to complete the square, the coefficient of x needs to be 1. The coefficient of y, so x squared, and the coefficient of y squared needs to be 1. And so I have to factor out the value in front of x squared. Factor out the value in front of x squared and y squared. We have to do them separately because we have our x variables and we have our y variables. And so this is up here and this is up here. And we are forced, we do not have a choice, we must. We are forced to factor out the number in front of x squared. So I factor out 3 right here, and that leaves us with x squared minus 2x. And then I factor out 3 from the second one, and that leaves me with y squared plus 4 over 3y. This part is a little bit tricky, so I am paused. Questions? You can always double check your work by falling back in, 3 times x squared is 3x squared. 3 times 2 is 6. 3 times y squared is y squared. 3 times 4 over 3y is 4y. And so I have not broken any mathematical rules. But that allows me now to complete the square, because I can now find the missing value for the x, and I can find the missing value for the y's. I'm out of space. All right, so to find the first number, that's going to be -2 divided by 2 squared, which is just going to be 1. So I'm going to put a 1 right here. To find the second value over here, that's going to be 4 over 3 divided by 2 squared. That's going to be 4 over 3 multiplied by the reciprocal. That's going to be 4 over 6 squared, which is 2 over 3 squared, which is finally 4 over 9. And so this number right here is going to be 4 over 9. That's really small. Let me make it larger. Questions there on how I found those missing values? And so now that I have this, I can put the numbers on the other side, but there is a small caveat, is that I cannot just go 1, I have to go 1 multiplied by 3, because the 1 that I entered is 3, is multiplying by 3 on the outside. And similarly, the 4 over 9 has to also be multiplied by 3. You can see how this is getting really complex. There's so many small, fine details. That's why I'm trying to pause. Questions? Yes, I have a +1 over here, and I don't have a +1 over here. The reason is 3 multiplied by 1. So it's actually, I'm adding 3 when I put the 1 in here. So I have to go 1 times 3. It's always 1 times the number on the outside. 4 over 9 times 3. Questions there?
No, sir.
But again, appreciate the fine detail. So this first one becomes x minus 1 squared with a 3 on the outside. This second one becomes y plus 2 over 3 squared. Again, for 3 on the outside. And then the last one becomes 4 plus 3 plus 4 over 3. I need to do the math. 4 over 9 times 3 over 1 is 12 over 9 divided by 3. That's going to be 4 over 3. Questions there? Good thing this is being recorded, right? And so that's going to be 3 times x minus 1 squared plus 3 times y plus 2 over 3 squared. I need to add these together. So I need a working column. 4 over 1 plus 3 over 1 plus 4 over 3 is 12 over 3 plus 9 over 3 plus 4 over 3. I gave each of them a common denominator of 3, so I multiplied by 3 over 3. I multiplied by 3 over, I am out of spacing. So now I have the common denominators. 12 plus 9 is 21. 21 plus 4 is 25. So that's going to be 25 over 3. Questions there about the fractions?
No.
And so one step remains. I have to then divide everything by 3. The 3's will cancel. And so that's going to be x minus 1 squared plus y plus 2 over 3 squared. It's going to be 25 over 9. And yes, I do owe you some math to show how I go from here to here. I'm going to do that in the working column over here. 25 over 3 divided by 3 is 25 over 3 times 1/3. That's going to therefore be 25 over 9. So this gives us this, and then that gives us that. This is definitely one you need to practice. My suggestion is you'd start by going over the video, watching me go through it step by step, and then trying one from the homework. Questions there? So now that I have this, the center is at 1 comma negative 2 over 3, and the radius is the square root of 25 over 9, which is better known as 5 over 3. Deep breaths, everybody, deep breaths. But that was a lot. So I am going to pause. I'll give us a minute or so to decompress. And if I have questions, go ahead and fire away. Miss Asma, I am not sure what you mean. R equals 16. I'm not sure when you send that message. All right. Any questions? Other than, oh my goodness, do I have to do this? After you practice a few times, it's not that bad. Plus, we will see this whole squaring things again. So it's good for us to get us in the habit, get us in the practice. All right. So that takes us out of this section. Let me just go ahead and start a new page. We are moving into functions and relations. I guess I should put it the other way, relations and the functions. A relation is any set of ordered pairs. Relations can be written in several ways. For example, they can be written as, I wanted 2,5. They can be written in a set notation. They can be written in a table formation, x comma y, 2, 3, 4, 5, 8, 11. Sometimes the x comma y is given horizontally because, you know, we just fancy like that. But all they're trying to simply say is that these numbers are related together, right? A relation can be given as a graph. I have this same relation right here. This is 2. This is 5. So you put a dot right here, 2 comma 5. That's 3. And that's 8. So you put a dot right here at 8. This right here is 4. This right here is 11. Put a dot right here at 4 comma 11. All of these right here are relation, the same relation. It's just given ordered pairs in different manners. One last way that you may not have seen before is that the relation can also be written in this format right here. 2, 3, 4 with an arrow, 2 pointing to 5, 3 pointing to 8 or mapped onto 8, 4 pointing to 11. A relation is just simply numbers that are paired together. Sometimes there's a reason the numbers are paired together. Sometimes there's not. There are lots and lots of relations out there. For example, you can have a relation between the capital and the state. How many capitals do I know? I know Tallahassee is mapped onto Florida. What's the capital of Atlanta? Atlanta is the capital of Georgia, right? I hope so. Atlanta mapped onto Georgia. Albany is the capital of New York. The point is you just have ordered pairs. The first value means something, the second value means something else, and the two things are linked. It can be a sentence, it can be an information, it can be a mathematical operation, and of course, for this class and our purposes, it will be mainly mathematical operations. Questions there? The initial values of the relation are called the domain values. The other set of the relation where it's been mapped onto is called the range of the relation. Your domain values, the values in the domain are called either the inputs or the independent variable. Either called the inputs or the independent variable. The values of the range are called either your outputs or your dependent variables. We have come across the idea of independent and dependent variables when we were talking about our equations last week. Questions there about the information? So you have your domain, you have your range. The domain are your values, are your inputs, are your independent variable. Your range are your outputs or your dependent variable. There are 4 kinds of relations. The first kind of relation is called a 1-to-1 relation. An example of a 1-to-1 relation is f of x equals 3x plus 2. In a 1-to-1 relation, every element in the domain is mapped onto 1 and only one element in the range. The second kind of relation is a 1-to-many relation. An example would be y equals plus or minus the square root of x. My domain and my range. The square root of 1 is -1 and +1. The square root of 4 is -2 and +2. In a one-to-many relation, one element gets mapped onto many or more than one element. The next kind of relation is a many-to-one relation. And in a many-to-one relation, an example, oh, I should write the word one out. An example of a many-to-one relation is f of x is equals x squared. And in a many-to-one relation, many values in the domain get mapped onto one value in the range. -2 squared is 4. 2 squared is 4. So many values right here are being pointing or mapped onto one value. -1 squared is 1. And 1 squared is 1. Of course, 0 squared is just 0. That's your many-to-one relation. And then the last kind of relation is a many-to-many. Now, these equations for those are a little bit harder to write, but basically, you have both things happening at the same time. You have many-to-one, so you have this pointing to one number right here. And then you have one-to-many. And normally, the equation for these are a little bit hard to write. Normally, they are piecewise function. But we haven't gone to that yet, so we leave that for later. Domain and range. Questions there on our relations. If I said I had an order pair, if I say I'm looking at two numbers and I'm putting them one inside a first set called a domain, one inside a second set called a range, these are the only four possible ways these numbers can be arranged when you talk about a mapping, or if you go from one value to the next. You have a one-to-one mapping. Every element just gives us one answer. A one-to-many, where one number gives us more than one answer. A many-to-one, where several numbers end up on the same point, and a many-to-many, where you just have chaos. Anything reigns. Questions, sir? You guys don't like chaos? Well, it turns out that mathematicians don't like chaos either. And because we don't like chaos, we decided that two of these are more important than the other two. We decided that your one-to-one and your many-to-one stand out in terms of the four relations. How do they stand out? A function is a relation where every element in the domain is mapped onto one and only one element in the range. Booyah, as they say. Aren't you guys excited? You now know what a function is? So why is it that I'm saying that those two, the one-to-one and the many-to-one, are the two that meet this definition of a function? Well, I would first like to point out the importance of a function. The reason why we care about functions and the reason why we like functions is because functions remove ambiguity. What do I mean? If I was to plug a number into a function, I get one answer. That's the key thing to a function right here. If I go up here to my lovely pictures right here, and I start at the number 1, if I plug in the number 1, there's only one answer I can get. That answer is 5. That removes ambiguity. That removes any mistakes, any quarrels, any issues, because I'm plugging that number in, I'm getting one answer. Same thing down here. I plug in -2, the answer I get is 4. That's it. If someone in Europe plugs in -2 into this function, they will get 4 as well. That's what sets functions apart, is that you always get one answer. In the other two, that's not the case. If I plug in the number 1, I actually get 2 answers, right? And that leads us to some amount of ambiguity. Well, is 1 the answer? Is negative? Remember, we actually came across this when we had to take the square root. We had to remember it's plus or minus 2. Square root of 4 was plus minus 2, and both answers were correct, right? That leaves us some ambiguity. Is the answer just 2? Is the answer just -2? Or is the answer both? With functions, that's never a problem, because for a function, everything is mapped onto one value. Questions there? Questions there? And that's what sets functions apart from all of its friends and families and neighbors and anything else in between. Every element in the domain gives only one answer. That's not the case, then it is not a function. So, for example, if I have this ordered set right here, 2, 3, 4, 7, 8, 9, and then 2, 5 right here. Is this a function? And the people said, somebody help me out here. Is this a function? The answer is no, this is not a function. How can you tell? If I was to put it in a domain and range, 2 is mapped onto 3, 4 is mapped onto 7, 8 is mapped onto 9, and 2 is mapped onto 5. The value 2 gives us 2 answers, and thus this means that this is not a function. Questions there? All right, we've seen that there are several ways of us that we can express our relation. I'm going to give you some of them, and I want you to tell me yes or no, is this a function? Is this a function? Number 1. Number 2. Number 3. And number 4. All right, 1, 2, 3, 4. The answer is either going to be yes or no. Go ahead and post your answers to the internet. I'll give you about 2 minutes while I'm waiting. Any questions? Everyone is able to find the discussion board?
When I try to post to it a reply for it, it keeps telling me I have insufficient permissions for some reason.
Let me go check and edit. Let me see if I missed something.
It didn't do it for our first discussion, but it's doing it now.
The due date is 6:30 today. That's not why. Also, points is graded. Try hitting reply to one of your posts. Try that.
So that's what I did try, but
Well, then try the reply at the top to the entire thing.
okay. It's still saying the same thing. And I think some people in chat are saying that it's closed for comments right now.
It's closed. How did that even happen? Close for comments. Why would it? Students have already submitted to discussion, so group. Yeah, that's fine. I didn't close it. I was talking to you guys. I didn't have time to close it. The due date is I have it due at 6:30. I meant to put 7:30. That's the problem. Thank you. All right, go back and now try again.
You want us to reply to like the discussion board or something?
Yes. It should work now.
It's working now.
Well, answers yes, no, maybe so. Oh my goodness. Right. Is it doing this? Never had this problem before. All right, are we ready for the big reveal? Are we ready for the big reveal? All right, let's roll. So for the first one, this is a function, yes. It is a many to one to many. It is a many to one function. So 1, 2, and 3 are all being mapped onto 0. This is a many to one, and that is a function. So that one is yes. Number 2 is also yes. Every element in the domain, if you look very carefully, is mapped onto one element in the range. And so therefore, this is a function. For number 3, the answer is no, it is not a function. If I was to take those 4 dots and I was to write them as ordered pairs, that's going to be 1, 2, then 1, 4. This is 1, 2, this is 1, 4, then 2, 2, and 2, 4. 2, 2, and 2, 4. And this right here, sorry, if I was to put this right here, 1 and 2, 1 gets mapped onto 2, 1 gets mapped onto 4. And so that's a one to many. And as we know, that's not a function. One element gets mapped onto many elements, right? And then the last one right here, yes, this is a function. And it can be a little bit hard to tell that it's a function, because in theory, you would have to take every single point and then put them in a table to see how it works. And so what we use is something called the vertical line test. The vertical line test, or the VLT as it notes, simply states that any vertical line that you draw must go through the graph exactly once. If that's the case, if any vertical line that you can draw, let me bring up my vertical line. This ruler right here represents a vertical line. Any vertical line that I draw on this graph right here, that vertical line will go for the graph exactly once. Doesn't matter where I draw the vertical line, that's why we use the word any vertical line will go for the graph exactly once. And if that's the case, then it is a function. If any vertical line goes through it exactly once, it is a function. Of course, if the vertical line goes through the graph more than once, we will see an example on Thursday, then it is not a function. All right, any questions there before we close up shop? Again, please make sure you have posted. That's how we take attendance. Any questions? All right, then you guys can have a nice day. If you have a question, you can always hold on to believe.
Have a nice day.
And see you on Thursday.
How we going?
It's going good. I take attendance through the online the discussion board. Did you post something in there? Just make sure you post something in there.